Today we're going to talk about logarithmic functions. A logarithm is the inverse of an exponential function. Y equals log base b of x if and only if b to the y equals x. So b to the y power equals x. Now this is only true if b is greater than 0, x is greater than 0, and b doesn't equal 1. One of the most important things I want you to remember is that the answer to a log is an exponent. The base of the log is the base of the exponent. Because y equals log base b of x and b to the y equals x, b to the log base b of a equals a. So let's look in there for a second. So see, this b cancels with this. You just are left with this a. And log base b of b to the a, again, the log base b of b part cancels, and we're just left with a. These are really important. It's really important that you remember these. I think it's also written in the notes later. Okay, so first thing we're going to do here is we're going to write each equation in its equivalent exponential form. So this takes some practice. You probably started it last year at the end of Algebra 2, but yeah, people don't always remember the rules. So here's how it goes. The base of the log is the base. This is the exponent, and that equals x. All right, let's try the next one. B to the third equals 64. They're not asking you to solve or anything. You're just moving the stuff around. So the base of the log is 3. 3 to the y equals 7. Now this brings up what I set up here. The most important thing I want you to know is that the answer to a log is an exponent. So come and look at this one. The answer to this log is y, and notice that y is the exponent. Okay, now you're gonna try these on your own. So pause the video and see if you can do these three, and then come back when you're done. Okay, hopefully you were able to get these, but let's write the answers down. First we have 7 to the 3 equals x. Of course, you can also have x equals 7 to the third. Doesn't matter which order you write that in. B squared equals 25. And finally, 4 to the y equals 26. Okay, next we're going to do it in reverse. So now we have exponential equations, and we're going to change them to logarithmic. So the first thing we're going to do is we're going to write the word log. 12 becomes the base of the log. Remember that the exponent is the answer, and the only other place for this guy to go is here. Okay. All right, next one. Log. Remember that this becomes the base of the log. The answer is the exponent, and the 8 has nowhere else to go. Okay. E. What is this E business? Okay, so log base E of 9 equals y. Now we're going to talk about this a little bit later, but this isn't just any E. This is that E number that we talked about in the last video. Remember how E equals 2.718, blah, 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 blah. So a log with a base of E, we actually have a completely different way to write that, and that is just ln. That means the natural log, but I think we get to that later. I don't know why it's called the natural log and then it's ln. Like, why isn't it nl? I don't know. I have no idea. Okay, so why don't you pause the video again and try these three on your own. Okay, let's see if you got them right. Log base 2 of x equals 5. Log base b of 27 equals 3. Log base e of 33 equals y, or ln 33 equals y. Okay. Let's try some evaluating logarithms. So remember I said that the answer to a log is an exponent. So let's take a look at this one, A. Log base 2 of 16. So there are a couple ways you can do this. In the beginning, it might be helpful for you to just say, this equals x. And then you can take this and change it into an exponential. You can say 2 to the x power equals 16. And then you can think about what must the x be. So one way to do this is to try to get these numbers to have the same base. So in other words, can 16 be written as 2 to the something power? And it can. 16 is 2 to the 4th power. Now see, if you have 2 to the x equals 2 to the 4, then the exponents just equal each other. So x is just 4. So that means that the answer to this is 4. So log base 2 of 16 is 4. It's not always necessary to do all those steps. And if you can get that log base 2 of 16 is 4 without this work, it's really okay, because that's where we would like you to get eventually anyway. But here's a backup plan if that's not working for you. All right, so let's come over to the second one. So let's say this equals x, and we'll change it to 7 to the x equals 1 over 49. So is there some way I can make this 49 into a 7? Of course, I can make it 7 squared, but it's really 1 over 7 squared. And then, because 7 squared is on the bottom, I could change that to 7 to the negative 2. And now I have the bases are the same, and if that's true, then the exponents are equal. So log base 7 of 1 over 49 is negative 2. Okay, let's try this one. We'll put the x over here. We'll change it to an exponential. And then we'll apply these same steps. Except for this time, the bigger number is on the left side with the x, but that's okay. So can I write 25 as 5 to the something? Yes, I can write it as 5 squared. 5 squared is 25, and that's still to the x power. And if you remember from exponent laws, you don't have to write this, but just look. If you have x to the 5th squared, do you remember what you do with these exponents? You multiply them. Power to a power, you multiply. You actually have the same situation here. So 5 to the 2 to the x is the same as 5 to the 2x equals 5. And if your base doesn't have an exponent, then his invisible exponent is a 1. So 2x equals 1. So x is 1/2. Okay, let's look at this last one. This one's weird, huh? Okay. Let's change this first to an exponent. So remember that roots can be written as fractional exponents. Okay. Then if I change it to an exponential, I'll get 2 to the x equals 2 to the 1/5. So x equals 1/5. Okay, so I want you to take a few minutes and I want you to try these 4 and then check back in when you're done. So pause the video. Okay. This one is one that you might be able to do in your head. So I'll show you that way now. So 10 to the what equals 100. 2, right? So this equals 2. But if you like the other method better, we can say 10 to the x equals 100. And of course, you can just say right now x is 2 if you're able to do that. Or you can physically make the 100 into 10 squared. Doesn't matter. Okay, B. 5 to the x equals 1 over 125. 5 to the x equals 1 over 5 cubed. 5 to the x equals 5 to the negative 3. So x equals negative 3. So the value of this log is negative 3. Okay. 36 to the x equals 6. We can make 36 into 6 squared, which is the same as 6 to the 2x equals 6 to the 1. So 2x equals 1 and x equals 1/2. And then this weird one, remember, so first change it to 3 to the 1/7. And then change it to an exponential. Okay. So I think this might be a repeat of what's above. Oh, no, it's not. Never mind. Okay. So basic logarithmic properties involving 1. Log base b of b is 1 because b1, is the exponent to which b must be raised to obtain b. Okay, so log base b of b is 1. So if I had log base 10 of 10, that would equal 1, even if it's not a number I'm familiar with. Okay, and that's because b to the 1 equals b. So this b to the first power equals b. Log base b of 1 is 0, because 0 is the exponent to which b must be raised to obtain 1. Anything to the 0 power is 1. So b to the 0 is 1. That's this b to the 0 is 1. Okay, let's practice some of those. So log base 7 of 7, if this matches this, the answer is 1. Log base anything of 1 is 0. End of story. So as long as the base of the log matches it's called the argument, but then those kind of cancel and you get a 1. And log base anything of 1 is 0. So those are important ones to remember. Oh, this is the one that was sort of written above. So inverse properties. So log base b of b to the x equals x. So basically, if you have this b matching this b, the answer is just the exponent. So that this sort of like cancels and you just get an x. So the logarithm with a base of b, so the base is b and the argument, that thing is b, is raised to a power, then the answer is just that power. And the reverse, which again, this was written up above, but b to the log b of x equals x. basically this stuff cancels and you're just left with x. B raised to the logarithm with base b of a number equals the number. Those I think are a little trickier to remember, but kind of your job. Okay, so let's look here. So if this matches this, then the answer is just 5. Okay, these 4s don't really matter. They could be, 492. It doesn't matter. As long as these match, the answer will just be the exponent. And if this base matches this base, then the answer is just 9. So let's try these ones. Log base 7 of 7 part goes away. We're just left with 8. 3 to the log 3 part goes away, and we're just left with 17. Okay, there's a little bit of space here because I needed to start farther down. Okay, graphing a log function. A logarithmic function is the inverse of its corresponding exponential function. So if you can graph an exponential function, you can graph a logarithmic function. For example, y equals log base 3 of x. Its inverse is y equals 3 to the x. And all other transformations occur as we've done all year with other sorts of graphs. So here's what I want you to do for graphing logs. The first thing I want you to do is I want you to make a table for the inverse, for 3 to the x. So I'm going to start with -3. And if I don't need it, that's fine. I just won't use it. Okay, so remember how we start this. I always start with the 0 because I like him better. So 3 to the 0 is 1. 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. And then when you make the exponents negative, it just takes my y values and makes them the reciprocal. Now, inverses, if you recall from really Algebra 2, because I don't think we did them this year, inverses switch their x's and y's. So that's what we're going to do here. We're going to literally take these y values, and those are going to be the x values. And I'm going to take these x values, and they're going to be the y values. And now you've got points for the log base 3 of x. That's how simple it is. Now, eventually, if you want to skip this step and just go right to this one, that's totally fine. But I figure in the beginning, you're going to want to practice that. Now, normally I like to make the graphs with you, but I sort of had like a technological error here, so I can't. But so on a graph, we're going to have these points of, let me pick a different color here. So again, we're looking at log base 3 of x, so this one. So that's 1, 0, 3, 1, 9, 2, 27, 3. This is not going to work for us. And then going up the table, we have over 1/3 down 1, over 1/9 down 2, and I can't really get that one in there either. And so here's the graph. And just like an exponential has an exponent on the x-axis, a log has an asymptote on the y-axis. Okay, so those are some things we're going to talk about down here. I kind of jumped the gun here. So notice that log base 3 of x doesn't intersect the y-axis. So that means that there's an asymptote of x equals 0. And that is a vertical asymptote, whereas the exponential has a horizontal asymptote. The only time it won't be this is if there's a horizontal shift. So basically, if there's a number in with the log like this, then the vertical asymptote will shift. That's the only time. Log base 3 of x has an x-intercept of 1 comma 0. That's this guy here. And let's talk about the domain. So log base 3 domain, that's what x can be. So notice that x can't be 0, and then it can be anything above, above 0. So log base 3's domain is 0 comma infinity, or you could write it as x is greater than 0. And what is log's range? Well, it does go down forever. It just approaches the x-axis but never gets there. But it does go up forever. It's slight, but it does go up forever. So the range is all real numbers, and it's always all real numbers. The only time that log base 3 would not have a domain of 0 comma infinity is the same time here. So if So if there's a horizontal shift or a horizontal flip, the domain will change. So for this one, for instance, this one I wrote over here, the vertical asymptote would be x equals -2, and then the domain would be -2 to infinity. If it was flipped, it would just be -infinity to that number. Okay, so let's practice some. So we have log base 2 of x plus 3. So first, we're just going to make the table of values for the parent inverse. So just 2 to the x. I think I have these already here. Yeah, I do. Well, there we go. So you can copy those down and then plug in all the numbers, right? So 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. You should be pretty quick at plotting those, making those table values now. And then, oh, I copied this wrong. I'm sorry. This is not true. This should be log base 2 of x. So that's when we switch our x and y values. Oops. No. You saw nothing. Okay. So we'll do this. So we'll copy this. No, really, copy this. Oh, it can't? Oh, no, it can't. Okay, that's fine. It doesn't matter. So that's going to be -3, -2, -1, 0, 1, 2, 3. Now we have to address this transformation. Now, because there's no parentheses here, this is a y change. So you could even picture it like this. That might be actually more helpful than anything. So the 3 is not in parentheses. So this is a change to y. So this is going to take all the y values and add 3 to them. And that's what we're going to do down here. So we're going to add 3 to all the y values. And then we'll write the new values over here. And so this column and these corresponding y values, this is going to be what you're going to graph to get log base 2 of x plus 3. Okay? So we have 1, comma 3. That's this one here. Oh, I need a different color. 2, comma 4. That's this guy. 4, comma 5. 8, comma 6. And here's all the other points. Now, the asymptote is still on the x-axis. I'm sorry, the y-axis. And you do need to draw that in. And this is just a log base 2 of x graph. You know, this has been shifted up 3. Of course it has, because it's got a plus 3 at the end. Okay. Let's look at this one. There's another error there I got. Okay. So now there's a 3, but it's in parentheses. So this is going to change x. This is a change to x. But remember that whatever happens to x happens in reverse. So if it says x minus 3, I'm really going to be adding 3 to all of my x values. So first I have my x values for 2 to the x and their corresponding y values. And then I switch the x's and y's, right? Okay, so this is log base 2 of x, and then I'm going to take all of my x's and I'm going to add 3. So that'll be 11, 7, 5, 4, 3 1/2, 3 1/4, 3 1/8. So this column and this column, that's who's getting graphed. Okay. So 4, 0. So that's, here we go. 5, 1, 7, 2, 11, 3. And then going backwards, we're over 3 1/2, down 1, over just a little bit more than 3, down 2. Okay, make sure that your graph doesn't cross that dotted line. It's probably better if you draw the dotted line first. And right here, that's how you're going to know what the asymptote is. So this is a log base 2 of x graph, but it's shifted right. Oh, no, not 2, 3. Okay, finding the domain of a logarithmic function. Okay, basically, you can't take the log of a negative number. So whatever is in the log function must be greater than 0. You can't take the log of a negative number, and you can't take the log of 0. That's it. So if you want to find the domain of a log function, take whatever is in the log function, that's the argument, and say that has to be greater than 0. And then solve it, and we get x is greater than negative 3. That's the domain. That's it. Not hard, it's just the remembering of it. And then, of course, an interval notation. That would be negative 3, comma, oops, geez, infinity. Okay? So if we want to find the domain of a log, we take what's inside the argument. We say it has to be greater than 0. We solve. And that's the end, folks. That's the domain. It can't equal 5, though, because 5 is where the vertical asymptote is. So it's not equal to. Okay, here's just some, just a couple of problems of, like using logs. Okay, so common logs. Common logs are logs with base 10. And that's called a common logarithmic function. F of x equals log base 10 of x is just written without the number. So I know invisible numbers are usually like 1s or 0s here, but in this case, log of x is really a log base 10 of x, but they're not going to write it. Okay, so let's look here. We have this word problem. Percent of adult height attained by a boy who is some number of years old. And f of x is the percentage of his adult height, and x is the years. So age 8. That means x is going to be 8. And this is a log with no base, so that means there's an invisible base of 10. So all we're doing here is we're just plugging in 8 for x. And this can be typed right into your calculator. The log button on your calculator is right next to the 7. So it's just to the left of the 7 and it's all in caps like this. Now, if you press that button, it's assuming that you want a base of 10. If you don't want a base of 10, we have to go somewhere else, and I'll talk about that in a minute. So if you type this in the calculator, you're going to get 75.567. So basically, by the time this kid is 8, he will have reached 75% of his, adult height. Okay, so here we have just a little, concise summary of some general log properties. So log base b of 1, of course, is going to be 0. We talked about that earlier. Log of 1, therefore, is going to be 0. So all of these logs over here, these just have a base of 10. Log base b of b is 1. Log of 10 is 1, because the invisible base on this log is a 10. Oops. Log base b of b to the x is x. Remember, those cancel. So log of 10 to the x is x. B to the log base b of x is x. 10 to the log x is x. So basically, until you're more comfortable, anytime you see a log with no base number, there's a little bitty 10 in there. They're just not showing it to you. And then last, we have natural logs. Logs with a base e is a natural log function. So we talked about that up at the top. So see this? That's not really a thing. It's really ln x, and that's what we say, ln x. And the ln key is right below the log key. So it's below the log key, and it's to the left of the 4 on your calculator. But the domain of an ln function, it doesn't matter, because the domain of any log function is the same. We would take what's in here, and we would say it has to be greater than 0, and we would solve. That's it. So in this case, I would subtract 3 from both sides, and then I would have to divide by -1, but remember, when I divide by negative, this sign flips. So there's your domain, which could also be written as negative infinity to 3. Over here, I could say x minus 3 squared has to be greater than 0, which it does, but if I square root both sides, I'm going to get x is greater than 3. That's not a great way to explain it. Oh boy. We'll just get rid of all that. So, you can't take the log of a negative number, right? We talked about that up top earlier. But when you put something in here, it's squared. So anything that would have been negative is automatically positive. So the only thing that can't be here then in this spot is a 0. So x minus 3 just can't be 0. So that means that x can't be 3. And I actually graphed this just to make sure, and it looks like a log base 3 graph. There's just 2 pieces, so it goes both way, like to the left and to the right. Okay, so try these. Make sure you can do these. So pause the video, then make sure. This one is x has to be less than 4. And this one is going to be x just can't be 0. And then we have another one of these little summaries here it's just the same but with a natural log. So log b of 1 is 0, ln 1 is 0. Log b of b is 1, ln e is 1. X, 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 x. Okay, we're almost done. Okay, so now this is pretty similar. It's just to the other word problem. It's just it's ln instead. So when the outside air temperature is anywhere from 72 to 96, the temperature in an enclosed vehicle climbs by 43 degrees in the first hour. So this models the temperature after x minutes. Use the function to find the temperature increase to the nearest degree after 50 minutes. Yeah, don't read too much into this. They're just asking us to plug in 50 for x. So in our calculators, we're going to type 13.4 times ln. Now, when you type the ln button, it automatically puts a parenthesis here. So it's really important that you close it, because if you don't, it's not going to do it in the right order. So just like when we did trig functions, you have to close this. And that gives us 41 degrees, which is really scary. Look, if it's already 96, right? 50 minutes, car goes up 41 degrees. Good Lord, it'll be 137. No wonder kids die in hot cars, God. Okay, so try the homework, and then I'll see you next time, and I can answer any questions.